Hey guys, I'm Katie Mays, and I'm in Stat 205. Today I'm going to be demonstrating a chi-square problem. Let's take a look at our question. Do you think tattoos have anything to do with getting Hep C? Remember, all these values are made up. In real life, we would take a survey to get this information. But in this chart, it tells us if the person has a tattoo or not, and if they got it in a parlor or somewhere else, or if they have no tattoo at all, if they have Hep C or if they have no Hep C. It is important to make sure you add your row and your columns to help you at a later step. Feel free to pause this video at any time to write down this information. This total right here is your number of participants. When you add your totals, it should equal this value and it should also equal this value. 713 is our number of made-up participants. On the next page, I have the equations that are going to be used in this problem. The first one is our expected equation, which is the row total times column total divided by number of participants. Feel free to write this down for a later time. Your next equation is your chi-square equation, which is your sum of your observed minus expected squared over expected. Your degrees of freedom would be your number of rows minus 1 times your number of columns minus 1. Your p-value will be obtained from table A61 in the loose leaf textbook. Be aware that this might vary depending on which textbook you have. Feel free to Google the chi-square chart as well. For this problem, we will be using the alpha of 0.05. Let's move on to our first step. Step 1. State your hypothesis. Our hypothesis for this question would be HO, tattoo ascertainment is independent of having a Hep C. And our HA would be tattoo ascertainment is not independent of having Hep C. Let's see which one of these is true. Step 2 is to calculate your expected values for each cell. As I stated before, the equation for expected is row total times column total over N, which is the number of participants. As you see, I have already worked all the equations out for you. Feel free to pause this video at any time to get your expected values. Remember to do this for each cell. It might make things easier for you if you lay it out in a chart like this. I repeat, feel free to pause the video at any time to write down information. Our next step, step number 3, is to calculate your chi-square. The equation for your chi-square is the sum of observed, which is our original data, minus expected, squared, over your expected. So you plug in the appropriate data, 20 minus 5.3997, you square the top row and divide it by 5.3997. You do this for each one of your rows and each one of your cells. You add them all together to get your chi-square value. Feel free to pause at any time to write down information. Your next step is to calculate your degrees of freedom. The degrees of freedom equation is number of rows minus 1 times the number of columns minus 1. Make sure you use this degrees of freedom equation. your degrees of freedom ends up being 2 for this problem. Our next step, step 5, is to obtain your p-value from chart A61. So let's take a look at our chart. As you see, I have the degrees of freedom row 2, if it'll focus. You have your degrees of freedom down this way, and you have your p-values down that way. So what you do is you look for your chi-square value inside the body, and we will only be using the degrees of freedom row. So you see, if you're looking at your own chart, that this last value is 10.597. That is the greatest value in this row. So we assume it won't focus, so just look at your own chart. This p-value for that value is 0.005. So we know that that is the lowest that this chart is going to tell us. We can assume that since our value is 54, that it is greater than 10, so it would be to the right of a continued chart. Which means our p-value would also be to the right of a continuing chart. If you look at your chart and your p-value is going across, your p-values go down as they go to the right. Your chi-square values go up as you go to the right. This is an important rule to remember. So we determined that our p-value is less than 0.005 because our data is off the chart. Remember what I just told you, that as your chi-square value goes up, the p-value goes down. This will help you when figuring out your values. Your next step is to determine if your p-value is greater or less than your alpha value of 0.05. Since your p-value is less than 0.005, it is also less than your alpha of 0.05. So you can state, and since we do not know exactly, we just say that our p-value is going to be less than our alpha. Our next step, step number 7, is to determine whether to reject or fail to reject HO. Remember this rule. If p-value is less than alpha, you reject HO. But if p-value is greater than alpha, you fail to reject HO. So, what would we do in our instance? Our p-value was less than 0.05, and less than our alpha, so we would reject HO, which makes HA true. Our final step, step 8, is to write an explanation for grandma. Since we determined that our HA was true, which, if you remember what HA was, it was tattoo ascertainment is not independent of having Hep C. We then write out a simple statement so that grandma can understand. Remember, do not use any stat terms. Make it as simple as possible. My explanation here is one of many that could be true. Tattoo ascertainment is somehow linked to getting Hep C. Remember that you're able to pause this video and rewind this video if you need further help. Thank you for watching my demonstration. I hope this came to some kind of help for you.